this is Mrs. Brown, and today is a brief overview of simplifying rational expressions. So a rational expression is an algebraic fraction whose numerator and denominator are polynomials. So here would be some examples of things that would be considered rational expressions. And what we want to do is start with excluded values. Remember, excluded values are things that make the denominator 0, and you can't have a denominator of 0. So when I look at this particular problem, the first thing I notice is that this is the difference of perfect squares. So I want to rewrite this factored. So remember, that's going to be m plus 3 times m minus 3, because when I distribute this, what happens is the middle term, which would be plus 3 and minus 3m, is going to disappear, and I have my two perfect squares at the end. So the excluded values are going to be both 3 and -3, because this -3 would make this 0 and 3 would make this 0. So I have two excluded values in this case. All right, so again, the same thing. I want to factor it. The denominator is what I'm concerned with. So I want to factor it. Okay. Factors of 20, 1 and 20, 2 and 10, 4 and 5. I need them to add together because this is a plus to make 9. So I'm doing 4 and 5. Everything's positive. Okay. So once I have it factored, I can figure out what's going to make it 0. So -4 and -5. So those are the excluded values for that rational expression. Okay. Right. So, if you take a look at something like this, if I have B times A and C times A, that's the same as B times A, C times A, and I can eliminate that A out of there because it's a common factor. So I can actually eliminate those common factors when I'm looking at it. And I'm just left with B over C. So if I look at this, at first glance, it may not look like it has any common factors, but that's definitely, I can factor that using the distributive property, and I can factor that one using the distributive property. So 4 is a common factor of the numerator, and 5 is a common factor of the denominator. Again, you're dividing this by 5 and dividing this by 5. And then if you look, I have a common factor of m minus 3, because it's 4 times this quantity and 5 times this quantity, which means I can get rid of that quantity, okay, which would just be 4/5. If I take a look at this one, again, at first glance, it's kind of wonky. So let's start by actually just multiplying the numerator. So that would be -30, and then it's r to the 5th, because remember, that would be considered r to the 1st, and it's the product rule. So r to the 1st times r to the 4th is going to be r to the 5th, because you're adding the exponents with the product rule. Now, if you look, I can take 6 out of 30, and I can take r to the 5th out. And I'm left with -5 over here. I've got 6r to the 5th on the denominator. Those are going to cancel. So this is just all -5, that complicated mess. All right, if I'm going to do this one, I want to factor any trinomials that I have. So it's going to be looking at it, factors of 28, 1 and 28, 2 and 14, 4 and 7. I need them to add together, so the only ones that work are 4 and 7. So if I take a look at that, I now have a common factor of x plus 4, so that goes away, and I'm left with just x plus 7 as my final answer. Okay, so factoring, whether we're factoring out the greatest common factor or factoring into two binomials, that's going to be one of the keys in order to simplify some of these expressions. Okay, if I were to ask you to find the zeros of a function, I'm looking for what is the numerator, what makes the numerator 0, not the denominator, because remember, I can't have a denominator of 0. So if I take a look at this first one, as before, the first step is to factor this particular expression. So I'm going to go over here and do that off to the side. Remember that when it's a minus, I'm actually looking for factors that subtract to give me the middle number. So this is 1 times 15 or 3 times 5. I don't have a lot of choices, but 5 minus 3 is 2. So when I'm setting this up, I'm going to have a 5 and a 3. And the question is, which is plus and which is minus? Well, because B is positive, then the bigger number has to be positive. So this is a plus 5 and a minus 3. So when I look, this is going to come out to x plus 5 times x minus 3. And I have that all over x plus 1. Okay, I can't cancel anything in this particular one, so the zeros are the two things that make the numerator 0. So for this one, it would be negative 5, and for this one, it would be positive 3. So those are the two zeros that I have for this function. So let's look at this one. The same thing, x squared plus 3x minus 18. It's C is minus, so I'm looking for factors that subtract to give me 3. And so when I do that, 6 and 3 have a difference of 3. And so I'm, again, going to set it up. I've got an x with a 6 and an x with a 3. This is positive, so the bigger one has to have a plus sign. If b was negative, then the bigger one would have to have the subtraction sign. And so I'm going to look at x plus 6 and x minus 3. In this case, I can simplify out x minus 3 because I have it in the numerator and the denominator and it's multiplication. So that goes away. So I get x plus 6. So what makes f plus 6 0? Well, it would be negative 6. So this only had 1 and this one had 2. Okay, I hope this helps, this brief overview, and have a great day.